Today we are going to learn about unit testing ML models, best practices. We will explore how to effectively write unit tests for machine learning models, ensuring their reliability and reproducibility. Welcome to our video on unit testing ML models, best practices. Today, we'll dive into the world of unit testing, a fundamental practice in software development that ensures individual components of a software work as intended. When it comes to machine learning, unit testing is not just about correctness but also about ensuring that our models are reliable and reproducible. This video will guide you through the essentials of creating effective unit tests for machine learning models, covering everything from understanding ML pipelines to automating tests for continuous integration.
Unit testing is a critical component of the machine learning development process. It ensures that the components of your model function correctly and maintain their intended behavior. Unit testing helps detect bugs early in the development cycle, saving time and resources in the long run. It also facilitates regular code refactoring, allowing developers to improve and optimize code without fear of introducing new bugs. By maintaining a suite of unit tests, you ensure that changes to your model do not affect its performance adversely. This is especially important when updating models or deploying them in production environments. Unit tests improve overall code quality by establishing a reliable codebase that developers can build upon with confidence.
To effectively unit test ML models, it's crucial to understand the components of an ML pipeline. An ML pipeline typically includes several stages: data ingestion, data preprocessing, model training, model evaluation, and model deployment. Each stage has specific roles and responsibilities within the pipeline. Data ingestion and preprocessing involve gathering raw data and transforming it into a format suitable for analysis. Model training is where the algorithm learns from the data. Model evaluation assesses the model's performance, while deployment involves integrating the model into a production environment. Feedback loops are established to monitor the model's performance over time and adjust the pipeline as necessary. Understanding these components helps identify which parts of the pipeline require testing and how to approach each stage effectively. Identifying testable units within ML workflows is a crucial step in the unit testing process. Start by breaking down complex processes into smaller, manageable units that can be individually tested. Focus on individual functions and methods within the pipeline, such as data preprocessing functions, model training algorithms, and evaluation metrics. Test data transformations to ensure they produce the expected results. Validate model outputs by comparing them against known benchmarks or expected outcomes. Ensuring reproducibility is a key aspect of unit testing in ML. Tests should consistently produce the same results when given the same inputs. By identifying and testing these units, you can pinpoint errors more easily and maintain a high-quality ML pipeline.
Mock data plays a pivotal role in the unit testing of ML models. It allows developers to simulate real-world scenarios without the need for extensive datasets. Mock data helps test whether models generalize well to unseen data. By controlling data characteristics, you can create specific scenarios to test how models handle various situations, including edge cases. Mock data reduces dependencies on external data sources, making tests more reliable and faster to execute. It also aids in testing the robustness of models by providing diverse and challenging data inputs. Using mock data ensures that your model performs well under a wide range of conditions and is robust enough to handle unexpected data patterns.
Automating unit tests for continuous integration is a game changer in the ML model development process. By integrating tests into C/CD pipelines, you streamline the testing process and ensure that tests run consistently with every code change. Automated tests catch errors and inconsistencies before deployment, reducing the risk of introducing bugs into production environments. This integration also enhances development efficiency by providing immediate feedback to developers, allowing them to address issues quickly. With automated unit tests, teams can maintain high code quality, improve collaboration, and accelerate the development cycle, ultimately leading to more reliable and robust ML models.
Unit testing ML models present several challenges unique to the field. Non-deterministic behavior, often due to random initializations or stochastic processes, can lead to inconsistent test results. Testing complex algorithms requires a deep understanding of the underlying mathematics and logic. Managing data dependencies is another challenge, as ML models often rely on large, varied datasets. Ensuring comprehensive test coverage without slowing down development cycles requires careful planning. Balancing the speed of tests with their accuracy and thoroughness is crucial to maintaining an efficient workflow. By understanding and addressing these challenges, developers can create more effective unit tests that ensure the reliability and robustness of ML models.
Effective unit tests in ML are those that thoroughly evaluate the key components of your pipeline. Testing data preprocessing functions ensures that data is correctly transformed and ready for model consumption. Validating model training algorithms confirms that models are learning as expected. Checking model evaluation metrics is vital to ensure that performance measures are accurate and meaningful. Testing deployment scripts guarantees that models are correctly integrated into production environments. Finally, ensuring integration with other systems, such as data storage or user interfaces, helps maintain a seamless workflow. By implementing these tests, you ensure that your ML models are robust, reliable, and ready for deployment.
Writing robust unit tests requires a strategic approach. Keep tests simple and focused on specific functionalities to make them easier to maintain and debug. Use descriptive test names that clearly state what the test is verifying, aiding in understanding and collaboration. Mock external dependencies to isolate the unit being tested and ensure that tests run quickly and reliably. Test all potential edge cases to ensure that your model behaves correctly under a variety of conditions. Review and update tests regularly to reflect changes in the code base and incorporate new scenarios. By following these best practices, you can create a comprehensive suite of unit tests that enhance the reliability and quality of your ML models.
In conclusion, unit testing is a crucial component of developing reliable and reproducible machine learning models. By implementing robust unit tests, you ensure that each part of your ML pipeline functions as intended and maintains its performance over time. Continuous improvement and regular updates to your tests are essential to adapt to changing requirements and enhance model reliability. We encourage you to implement the best practices discussed in this video to create effective unit tests tailored to your ML workflows. Thank you for watching, and we hope you feel empowered to enhance the quality and reliability of your machine learning models through unit testing.